Good morning, everyone, and welcome to the IMAGIN Webinar Series. It is April 1st, and we are on the webinar series installment number 10. This morning, we have Andy Skelton from the City of Lansing presenting on real-time plowing, AVL, and GeoEvent server at the City of Lansing. Want to take just a minute or two here at the beginning to go through a couple of housekeeping slides and give you some information, and then we'll get the presentation turned over to Andy. I want to thank this morning our webinar series sponsors that we have so far, and those include Fishback, Giffords Webster, and BSNA Software. Three very widely varied technical organizations that can help with GIS and data planning for your organization. So make sure to look them up if you're looking for any data or GIS needs. And we want to just say thank you to them for sponsoring the IMAGIN Webinar Series. Oops. The next couple of webinars are already scheduled. On April 15th, we're going to have aerial imagery, a rapidly evolving technology for the future of small cities, presented by Tyler Bale and Kevin Korth. And then on April 29th, we'll have Brian Wooden from the State of Michigan Land Bank presenting on Confessions of a Part 107 UAS pilot. So make sure to check out imagine.org and go to the webinars page to get registered for those, to get all of the information and notifications. A couple of housekeeping items today. We are recording the webinar, so we will post the recording and the slide deck from Andy in the coming days. Please use the chat box or the questions box, depending on how your view and your device works, to post your questions. Andy's going to take questions, I believe, at the end. We've got some time allotted there. So post your questions and we'll address all the questions at the end. Again, we're being recorded, and check out the website for more information on future webinars. And with that, I'm going to go ahead and hand over presentation to Andy, and we'll get started.
All right, good morning, everyone. Well, been spending the last couple of years getting GeoEvent server up and running here at the City of Lansing, and it's been an interesting ride. And I know that this is kind of an evolving technology that a handful of other cities across Michigan are looking at perhaps implementing. And so I just kind of wanted to share with you guys my experience with that, because it's been interesting. So a little bit, what is GeoEvent server? It's basically this server package that is available from Esri. It's automation of data update. And you can throw a whole bunch of different inputs at it. You know, you can use JSON, GeoJSON, RSS. You can get data through REST endpoint. It's a very flexible piece of software. And then you can take those inputs and just kind of filter things out that you don't want or need, transform data. You can enrich data, take an incoming point and throw it up against a feature and get information about that feature and enrich that data and move it along. It's also a very customizable experience as well. You can write your own custom processors. And in fact, I actually use a couple of them. I did not write them. I got them through Esri. But you know, you can use a custom processor to delay data. You can use them to build vehicle tracks, enrich location data. And then at the other end of it, you also have a wide range of outputs as well. Again, feature service is probably the most widely used. And certainly if you're here at the City of Lansing, you can set it up so that it sends an email. You can set up stream services. You can use JSON, GeoJSON through a number of different formats. You can even tell it to set up to send out a text message. In the case of, say, a wastewater treatment plant, something goes so far out of the normal that somebody needs to know right now, you can tell it to send a text message. You can output as a CSV. You can also and send out to various big data formats as well. So starting here with the City of Lansing, back in 2018, Public Service came to us and said, we want to be able to track our trucks better. And so we initially started working with Verizon. We sat down with Public Service, Verizon, and us here in the IT department. Started talking a little bit with Verizon and decided that it's a great product, but not exactly what we're looking for. We then started looking at T-Mobile, which actually resells GeoTab, which is a company based up in Canada. And we're very happy with that. They have a really great product, but their UI we discovered wasn't what we needed it to be. In the case of, say, snowplow, if we wanted to find out along a specific street segment if any trucks had been down there, well, basically the process that we had to use using GeoTab was select 5 trucks, see if any of them were anywhere near that street segment. Nope. All right, select another 5 trucks, and it just was a really, really cumbersome process. And so that kind of necessitated the need for us to start ingesting this data into our Esri environment, so that we could have truck tracks, put in an address, and see when the last time any truck has been down there. Of course, which is useful during plow ops. If somebody's mailbox gets whacked and they try to blame us for it, we were able to say, no, that wasn't us. We don't have a truck that's been down that during any specific time. But it's also really useful in maybe trash disputes. Somebody said that their trash cart wasn't picked up, where we actually can tell, okay, first off, was the truck even down there, down that street? And so it gives us a good starting point. We also had a handful of future needs, going back to being able to pull, to send data into a big data repository. We want to be able to start pulling that route data into our data warehouse. And so we can start looking at historical truck routes. Where do the trucks like to go during a snow event? How do the trash trucks drive their route? And at least I'm not a fan of when you open up the map in GeoTab, you don't actually see anything right away. You have to tell it, I want these trucks before you start seeing it. Personally, this might just be a personal preference, but if I open up a map to track trucks, I want to see trucks right away. I don't want to have to tell it, which ones I want to see, which ones I don't want to see. I want to make that decision after. And yeah, you can break them down in GeoTab by department, but in the back end, but it's not the most intuitive process that I've found. And it's just, again, going back to, I want to subtract trucks. I don't want to have to add them. And so this is kind of what we have to work with on the GeoTab end of things. And I mean, it works. It's a solid product, but it didn't fit our need. And so we decided to move on. And for the setup, I thought was actually fairly interesting. Installation went like just about every other server product I've come across. ArcGIS server, portal, same process. It's a great wizard. And 15, 20 minutes later, I had the server stood up and ready to go. Config, on the other hand, I found to be difficult. There are tutorials that come with the with all of the installation files, but I'm sure some of you have run into this before, where it didn't seem to quite match reality. Things were different. It may have been, written for an earlier version where things are in different places or just don't exist altogether. But at the same time, despite the gaps, those tutorials were enough to where I could get a basic input set up and a basic output, and I could see trucks moving around on the screen. And so the way that we have it set up here for us, as we recommend that GeoEvent server and your posting be on 2 separate machines. And so that's what I've done. I have one server that has the GeoEvent add-on itself installed. And so it's receiving the event, it's doing the processing, and it's then spitting it out to my portal deployment, the portal for ArcGIS, which is on another machine where it can do its own thing and handle that input, handle the map requests, not just for my AVL, but for a lot of other maps as well. So once you have that set up, okay, how do you use it? That was another difficult thing for me to figure out. I come to liken the process of building out the logic to be very much like programming. So if you're a great programmer, then you might find this to be very easy. I'm mediocre at best. So it takes me a minute to figure out a valid logic pathway. As we offer great training, the training that I attended was the ArcGIS GeoEvent workshop. I think they still offer it, but you might want to double check. They do offer other great training sessions for that. So it reinforces the tutorials, and I think they actually use the same PDFs that come with that. But the advantage in sitting in on this training is you have an entire day to look into it, to mess around, to make mistakes, and you also have live direct access to an expert, the one who's putting on the training. And so you can shoot them a message and say, hey, this isn't working quite right. What do I do? What did I do wrong? And how do I get this set up right? And also just reaching out to other users across the Midwest and their own real world experience with it. A handful of years ago, I was lucky enough to be sitting in on the CityWorks Regional Users Group meeting that was here in Lansing, 2018, somewhere around there, 2019, I believe it was, where Battle Creek mentioned during one of their presentations that they were using GeoEvent. And so I reached out to their administrator at the time, and we just been going back and forth. And I understand that they have since moved on, which is what it is. But during the time that we talked, I mean, it was huge help. Tips here and there, commiserations, complaints, and also the chance to sit down with a screen share, over Teams or WebEx or whatever, and just have a look at how the other has things set up. The way that they have their logic might be different to the way that I do that. And not just Battle Creek as well. I reached out to Lakeville, Minnesota, in the Minneapolis area, because they actually have what I think is a really good snowplow tracking map. And I reached out to them. We had a great conversation, and I actually learned a lot of things from them about how GeoEvent does things. So going kind of back to how we use it, consuming the AVL data, we like I said before, we use GeoTab for our provider, and they actually have a really nice out-of-the-box connector that works great with their API. As we maintain it, that was not originally clear to me. I actually wound up submitting a handful of help desk tickets with GeoTab on it, and they were looking at it and they couldn't figure out what was wrong on their end. Eventually, they discovered that I was using that connector, and so they told me, go talk to Esri. And so I did, and what the issues that I was having with was trying to figure out how do I even set this up so that I can get data in. And I'll show you the connector here in a minute, but it turned out I just didn't have the right URL and other connection information. It simplifies the ingestion of GeoTab data. The way that they have their feed set up is they actually have a handful of different message types. The log record, which is the one that I'm most interested in, that contains information about where the truck is, what it's doing, how fast is it going, things like that. But it also has other messages as well, such as the status message. And that's where diagnostic data for the truck tends to reside. Things like, does it have an engine warning light on? Is the fuel pressure high? Is the gas something up with the gas? And also the just general trip data as well. And then so it'll take all of those different message types and it'll send them and assign them to the respective event definition, which are required for just getting a general schema of the data and so that GeoEvent knows what you're working with. And actually, one thing that I kind of was not aware of, and a pitfall here, with GeoTab, there are actually two message types, diagnostic message types, that with each call will pull gigs upon gigs of diagnostic data. And so, you're making these calls every 30 seconds or whatever you may have set up. And you're pulling gigs of data every time. That doesn't really go very well. GeoTab were not happy with me. Crashed my system. I slowed down, theirs way down. And eventually, just from back and forth, we figured it out. I actually kind of pushed back on them saying, hey, I didn't know that this was going to happen. Don't be upset with the documentation on this. I had no idea. So sorry, I'll stop doing that. Won't happen again, but don't be angry at us. Long story short, leave the get fault and get exception data option set to no on that. And so the data that we have coming in, I'm actually pretty happy with it. It seems to be pretty accurate. It's just looking at where the trucks are, just raw data feed within a minute between when the truck pings and when I see it. So it's actually really, really quick too. So I'm very, very happy with it. At one point during the early stages, I actually, for kicks and giggles, threw our imagery in And I was actually able to tell what lane the truck was driving down a street. It's that accurate in some places. I could see where it would move over a lane and then move over into a turn lane and see that turn right on the map. And I lost a handful of afternoons just watching trucks drive around. Pretty fun. I do have some issues with points coming in out of order, but you can actually set that up, and I'll show you the logic chain in a moment to filter those points out. So it's not difficult to address them. And so that's what the connector itself looks like. You've got, of course, you need to assign it a name. You tell it the API that you're pointing at to get the data. In my case, that serve, and then you tell it, how often do you want to pull the data? It's 30 seconds here, and then so you need to have a user set up in your GeoTab organization, and so that's the account that's actually grabbing and pulling the data. And during that incident, I had actually set it up to use my actual account, so I didn't have anything set up at that point. Probably should have done it a little bit differently. And so they actually thought it was me pulling those gigs upon gigs upon gigs of data. And so which is why they came out angry at me. So definitely you might want to look into having maybe a service account or a generic account pulling that data, something that you can tell actually use GeoEvent pulling that data. And then where within that organization. And then you can kind of, down below all of that, you can see where you tell the connector what records you want to pull over. And you don't want that fault and that exception event data. And so the workflow that I have kind of down next to it, that is just an example workflow. This is actually the workflow that I use to update street segments as to whether or not they've been plowed. And to me, it really reminds me of model building in the way that you set things up. You drop a filter in, or you drop a processor in, it opens up a new menu, you tell it the specifics, and then you wire it up and away you go. And then down below at the bottom here, this is kind of how you filter out those out of order events. And so you take the date field, which the message has inherent, and you convert it into a long, and then you've got the current date time. Both of these as a long data field or field data type. And then you grab the difference to tell how long it's been since that date timestamp and the current time. And because I have things set up so that there's about a 90-second delay, anything older than that 90-second delay gets removed. And so I've had pretty good consistent luck in making sure that my points are in order, there's nothing wrong, nothing bouncing all over the map that shouldn't be. Although speaking of things bouncing around the map, I've also noticed that, especially with my processor, occasionally every now and then I'll find a truck that has its VIN get removed from GeoTab. That's kind of a problem on my end because GeoTab requires a unique identifier for each event so it can track. It's called the track ID. And in my case with the AVL, I actually use that VIN as the track ID. Well, sometimes GeoTab loses that. And so I get events that don't have a track ID, which kind of tends to bring up its own problem, and I start seeing spider-webby lines all over the map. The only rectification that I have for that right now is to either filter out those events that don't have a track ID, which keeps things clean, and then I have to go to our fleet manager to tell him to go into GeoTab, reboot the tracking device in that truck so it'll actually populate that VIN field. And so that's just something that we're constantly having to address, and we're needing to work with GeoTab on fixing that. But that doesn't happen very often, so it's not a major concern for me at the moment. For the snowplow map itself, in 2019, Public Service said, we want this to be built out. One public map, one internal map. Public map, less informative, but it gives the public an idea. One internal map that they can pull up, see where the trucks are, plus or minus 90 seconds, search trucks, search where they've been, and kind of go back in history and watch over time their progress. But kind of going back into the public map, is we want to inform the public. One of the biggest sources of calls that we get to public service in the winter are people just wanting to know, when is their street going to be plowed? And they almost get flooded with them, especially during a major snowfall. And so we wanted to cut down on that. We saw a lot of usefulness in MDOT's map, the MyDrive, and that was actually a source of inspiration for me. A lot of ideas came from that. But not only MDOT, but Iowa DOT actually has another really great tracking map. And I actually took the idea of using weather information and pulling that in so that people can see, where the precipitation is. And again, going Lakeville, Minnesota had a lot of really great ideas that I haven't been able to implement yet. But what I really liked about their map was it was a very clean product. Instead of having a track line, they managed to get theirs set up so that it would put in dots for that trail. And Ann Arbor also has another really good map that I use for inspiration as well. And another thing too that I actually haven't seen a lot of elsewhere, Esri's demonstrator that they built out to show what's possible has the street segment called out. And so you can actually click on a segment and it'll be one color. If it's not plowed, it'll be another color once it's been plowed. You can click on it, you can see that it's been plowed, you can tell when it's been plowed. And it's having that much more information at a quick glance. We really wanted that. But that we've discovered to be easier said than done. As a matter of fact, I honestly think it was the hardest thing to get configured. And so we wound up reaching out to GIS Inc. to help us with that. And so over the this past winter, we got together a really good usable product. And we talk about, we started talking with them late winter 2020 over the summer discussions. What can you guys do? What kind of a product? What's it like working? And then finally, by the autumn of 2020, we had an agreement with them, and I really enjoyed working with them. They had great ideas. It was especially useful to have a consultant to bounce ideas off. And we actually wound up having them also write a script that will take our track lines and then snap them to our street centerline network. And so that really cleans up the map. So instead of having spiderwebby lines all over the place, now we actually have a much cleaner product that matches our road network a lot more. And so ultimately what we wound up deploying this past winter, or perfect timing actually, for that snowstorm in February 2021, when basically the entire southern half of the state got, a foot of snow. And so what we wound up deploying here is this map right here. And so we can, look in, zoom around. Here's those streets that we have. We can tell that it's been a truck been down it, and you can tell that the last time a truck has been down it was apparently March 1st, 8:07 in the morning. And so one thing that I actually kind of want to call attention to here is we're not actually saying plowed and not plowed. So once we got all of the segment update logic set up, I started talking with the supervisors who oversee the snow plowing process at our operations and maintenance division. And the very first question that I had for them was, okay, what do you guys consider a plowed street? And come to find out, they don't have a number of passes that they consider a street plowed. A street is not considered plowed until it is clear edge to edge. So that could be one pass, that could be two passes. In the case of our major street, that could be 6, 7, 8 passes. There's no set number of passes. And so that kind of threw a wrench into my whole plan here. And so just kind of bouncing back and forth with them, we finally came up with not so much changing the logic to try to figure that out, but changing the wording. And so now, instead of plowed, not plowed, what I have is not plowed and then passable, which is to say, a truck has been down here at least once. You're probably going to be able to get down it. Whether or not it's actually cleared edge to edge, we're not going to say one way or another, because that takes multiple passes and there's no set number of passes for that. So it's just kind of something to think about if you're looking at getting this set up. And so another thing that you'll notice here with the map is I actually don't have neighborhood streets on them. The thing that I ran into with creating all of these polygons is the creation process actually creates a lot of overlap. And I have yet to find a good way to automate that. And so it was me going in with ArcGIS Pro and zooming right into each intersection and editing the geometry so it doesn't overlap. Kind of a difficult, time-consuming process, but I haven't found a way to automate it yet. And so that's, given the sheer number of neighborhood streets, I haven't managed to get something up yet for that. But it's in the works. I expect to have it by next winter. We'll see. Hopefully, I'll get it done by then. So, kind of looking at the logic here behind how I take that location data and get it so that it's spitting things out. The first thing that I want to look at here and try to address is the fact that input from GeoTab going back to what I said earlier, how there are a handful of different message types, they all come in. I cannot set up that input to filter them out. I have to do it within the process itself, the processor service itself. And so the very first thing I do, I get rid of all of those status messages, and so that I'm only getting the log record, which contains the truck location, the speed, and things like that. And then I have to do a handful of field manipulation due to the fact that one of the later processors actually does not like the field type that gets assigned to the speed. And so I changed that, which is, and of course I can't have two fields called speed, that would confuse things, so speed to velocity. And then the next thing I do is I maintain a list of all of our snow removal vehicles. And so I take that list and I throw it into this filter. Well, anything that's not a snow removal vehicle gets filtered out. So now I'm just looking at the plow trucks, where they are, that kind of a thing. And here's my temporal order filter. You just, again, get rid of points that aren't in sequential order. And then so one of the things that I was asked to put in by our operations and maintenance folks is a delay. They don't want people to mess with their trucks. And that's a really valid concern. I have not seen that happen, but it doesn't mean that it won't. So they don't want that risk. And so that delay pushes everything out by about 15 minutes, I believe, is what the public map is set in. And then so these next two calculators here, I kind of have a fork here. And so these next two, the motion calculators, one of the things that I don't get with the input data for the point is I don't get fairing data. And so the point calculator calculates that bearing for me. And so I can now take that information and apply it to the symbology and get that arrow pointing out the way that it needs to be. So it's not just an arrow pointing north, even though the truck is heading west. And then changing the schema so that it matches out what I have on my feature service. And then with the point data, again, to kind of obfuscate my data a little bit here, I've got a filter here that filters out trucks that are moving underneath a certain speed. In this case, it's 10 miles an hour. The reason being for that is I don't want the public to know where we store all of our trucks. I don't want them to know that location of our yard. And so I'm approaching it of the logic that trucks aren't going to move very fast in the yard, if they're moving at all. And so anything under that speed threshold, especially if it's sitting still, it'll filter out. And so it won't show up on the map. And so the reason why I use 10 miles an hour, actually, and why I don't use 0, I've noticed that even if a truck is sitting still and turned off, the drift that you see with GPS receivers, right? Because they're not always going to be centimeter accurate. So you'll start seeing that drift, which causes that filter, or it causes that calculator to go, oh, a truck moved, there's a speed. Suddenly, that truck is showing up, even though it hasn't moved at all. And so that kind of helped me address that. It also helped me address the fact that trucks are going to drive slowly around the yard as we prepare to head out. And so the second point here, one of the things that I discovered is I don't have a good way to draw track lines within GeoEvent. And there are other options available through Esri, but talking with Sarah Schrader, our rep, because that was about the only thing that we were looking to do, that option wasn't really the best fit for us. And so I went out, I did some research. This motion calculator came up. It was great. Just one thing to be aware of, that motion calculator was never designed to be used with AVL. It works. In fact, I think it works great, but it does throw errors. I do have occasional issues with it, but until I find something better, this is the option that I'm going with. And then so that third part that you see coming out of the delay processor is just going back and compiling historical data. So we can take a look later on if there's a dispute. Again, property owner saying a truck didn't plow their street, and it's a week after, we can bring up that historical data and say, no, a truck actually did go down, or no, a truck didn't go down. And so we have the historical data. And then finally, what I want to eventually do, I don't have this built out, is actually to get a link to our data warehouse, so we can start pulling that into our data scientist's realm, and so he can start doing his magic, and we can get a better picture of what our truck is doing. And then another screenshot of the logic that I use for my road segment updating as well. So pulling out the street IDs and filtering out the ones that don't have a street ID, because I do get occasional points for that, where that happened, and then just updating it, and then saying reducing out the fields that I don't need, and then shoving it out to my feature server. So we had a lot of really good reception on this. I think it's a great start. I think it's really captured the attention of what we can do already with GeoEvent. And so now we're starting to think, okay, where else can we apply this? One of my test beds actually, where that I had set up and trying to figure out how to get this going, I actually wound up using our trash truck, because I know reliably 4 days out of the week, those trucks are out and moving around reliably, consistently. And so that kind of led me to also start building out an example of maybe how we could apply this technology for our trash trucks. And so now, we can see where our trash trucks are, and not only see where our trash trucks are, but start bringing in data from our asset management, which is CityWorks. CityWorks has a really great functionality where we can take our city searches, save them as what they call an EURL, and put that up on a map. And so I have 2 URLs in this map, one to take a look at instances where we might have a pickup that got missed on our regular route, or a delivery that we need to do, or a move, or a repair. And so, I think this would be a really great tool for our main trash office to take a look. Okay, I have this service request here. What's the nearest truck? Oh, it's going to be PS 8949. Call them up on the radio and say, hey, go to this address. Do this. Here's the city. Here's the work ID number. And it just streamlines the whole process and making it easier for emergency one-off events to be handled. Another thing that we're looking at doing is taking that historical route data and running it through data science practices and figure out, are we currently driving the most efficient route? Do we need to perhaps tweak them a little bit? And actually, our snowplows don't have any set routes. Basically, the way that we've been handling it is our drivers get handed a map with an area highlighted, say, and get told, go plow this area, and then we leave it entirely up to them as to how they do it. It worked great. You know, we have, I don't know how many years now where we've been doing that, and it gets the job done. But the question also has to be asked, is this the most efficient way of doing it? And of course, pulling that data in the CityWorks, putting our truck locations on the CityWorks map, but also getting a better feel for our material usage. We know that our salt spreaders apply at a certain rate. Well, we can take that rate, cross it against the mileage driven that we're getting from GeoEvent, and hey, boom, right there, you know, we have an idea of how much salt we're spending, or we're spreading, and how much we're spending per snowstorm on salt application. And then, you know, you don't have to use it just for AVL. A really good application that I'm kind of wanting to explore more is we're looking at increasing building efficiency. If you know, utilities might have an API that could be hit, so you know, every 12 hours or so, we hit that API, and right there we know how much gas the building is using, how much electricity is being consumed, and just tracking those trends, you can get a really good sense as to how efficient your buildings are and where the hot spots are, and where you might need to start tweaking. So, you know, I overall, GeoEvent itself has been well worth our time. It has a steep learning curve, but if you expect that, then it's not as hard to overcome, as we have great training available. You know, just from professional organizations such as this one, you know, learning who else around you is using it, how do they use it, and just overall, I feel like this has been an incredibly useful experience and tool that we have made available. So thank you very much for listening to me yak on about this. Contact info is right there, and I will throw it back over to Tom for a question.
Thank you, Andy. Great presentation. Again, anybody, if you have questions, use that questions box. So far, we don't have any questions that have come in. You covered your process, I think, pretty well, Andy, and so I just appreciate that. I guess I'll throw out one quick question. If you had one major, I'll say, heartache or hiccup during the process of building this, what would that have been? What was the hardest point of getting this implemented?
A couple that come to mind. Just the initial setup, trying to get used to the way that the configuration is set up. It is completely different to how Portal or Server handles that. And so I was having to get used to the way that things are. The manager is completely different, and just getting used to that layout. So that was probably the hardest thing for me, just that initial, how does it do things?
Well, good. Well, again, thank you. We got just a couple of comments of thank yous for the presentation. And Tyler Prawl says, thanks, Andy. Fun to hear about the project from beginning and we're happy to be able to provide some support along the way. Neil Sabin says, are you aware of any agencies that currently utilize GeoEvent Server to keep track of material that is spread by the plow trucks?
Not entirely. I know, I believe Battle Creek actually was looking at trying to do that. I don't know if they have that implemented, and it's certainly something that I want to implement as well. But again, we haven't gotten that far yet.
Okay. And then Charles asks, what were some of the key elements that motivated your team to seek third-party help?
Just the need. The fact that we've been working on this since 2018 and have spent, you know, a year and a half, 2 years trying to get to where we are. And toward the end of that, we realized, okay, we need to speed this up. And so that's when we made the decision to reach out to Tyler Crawl and his team at GeoEvent.
Good. Well, I think that's all the questions that have come in. Again, Andy, just thank you very much for sharing your experiences. I think it gives us a lot to think about as we may consider for our own organizations whether or not some of these technologies would be assistance. One last one came in. Could you elaborate on where the script fits in relative to the GeoEvent processes? That's from Ryan.
The snapping script itself is actually set up that is a scheduled task, believe it or not, on the server. That kicks off every minute or so on as a Windows scheduled task. So that's actually kind of outside the realm, and doing that those edits to the feature layer itself. That's kind of how that works.
All right, great. All right, well, anybody that has additional questions, feel free to get them to Andy or send them to IMAGIN, and we will make sure to get them to Andy so that we can have some follow-up conversations. I want to thank you all so much for attending, and just remind you that we've got an April 15th webinar on aerial imagery for small cities, and then April 29th from Confessions on a Part 107 UAS pilot. So thank you all for attending. Thank you, Andy, for your presentation. And with that, we'll wrap up our webinar for today. We'll see you soon. Thank you all.
Thank you all. It's been fun.